a matter of fact, if you look at the complete TV production and distribution pipeline, I would argue that 75% of the technology is on the production side. So we're going to talk about how we have, with our best efforts, moved much of that to cloud and internet, i.e. a best effort platform. And broadcast production is by tradition not very much best effort.
And together with Agile Content, we are trying to turn the production side upside down.
And as in all businesses, you tend to focus on what you can manage. And if what you can manage is what you have inside this walled garden, you start focusing on and defining quality in those parameters that you can manage, including like quality is then defined by technical KPIs like resolution and like how many bytes and bits you have for the colors and stuff like that. So you tend to optimize your organization according to technical KPIs rather than what might actually be more important than the technical KPIs. So one of the things that we're trying to do is to ask ourselves, what is quality TV really nowadays when you have like the TikToks and the YouTubes and stuff like that, that you need to position your broadcast programs among.
New profession in SVT called remote operator. These are placed in Malmö and Göteborg and runs about 11 different studios. And there are only 13 in total today running all these shows. This is built with quite old technology. Being launched in 2018, it was thought out years before that, so it's mainly built with the old SDI technologies, but the production flow and the way of producing is very high efficiency and run by a one-man show. Want to reinvent putting the distribution side closer to the production side and reinvent under the hood of this system.
So what have happened? Why can we do this now, these big changes? So a few things. First, we have highly capable broadband networks today. And a lot have happened just the last few years. Now in Sweden, we've had fiber for quite a while, but on a more global scale, last 5 years, the average bit rate of the bandwidth have improved a lot. And then now we have new broadband networks like 5G and so on coming out that also offers really low latency. And low latency is very important when you do TV productions. Another thing, cloud platforms has also been around, but the last few years they have matured a lot and now starts to offer the capabilities that you need and the reliability you need to do broadcast production. And then we have GPUs, driven by gamers, but also to some extent cryptocurrencies. We now have a lot of highly capable GPUs available not only on like stationary servers, but also in the cloud nowadays.
When we talk to the large camera manufacturers like Sony and Panasonic, we set up our definition of what a camera needs for our production ways. When we walk through that list, they always put up their phone. Their cameras do not match what we want, but the phones today is a highly competent camera with all the stuff that we want built in. SDKs for the camera, SDKs for the operating system, and of course a great lens, and now 5G. So that picture there is actually just an iPhone tacked to a really high expensive glass.
So we had to do some stuff in order to achieve this. So we had to sacrifice a few sacred cows, including the tradition of working in silly high bit rates. We're talking the bit rate on SDI signal, if you work in HD, is 1448 megabit per second. And then in the end, when you distribute this, we are down to like, 5 megabit per second. So one could ask, why are we working in those super high bit rates in production when in the end of the day, what the viewer gets is much, much less. So we had to sacrifice some of that. We did get a solution that it's smarter, much faster and flexible. It's also distributed, so you could produce the Eurovision Song Contest from your living room on an iPad, if you would like. I mean, conceptually. I don't think Swedish Television would do that, but you could. First, we built a solution where you can register and manage cameras and resources that you use in your production. You can, from the same system, create a production by selecting which cameras and which resources you want to have in a particular production. And then you orchestrate the resources needed for that. So if you need more servers in order to cope with the incoming feeds, then you spin up more servers. So the first step after the cameras is capturing the video. Capturing the video, you can do that either in a server that do the capturing, so you plug in your cameras to that server. If you have, like Dennis talked about, a smart camera, maybe a mobile phone, you can run that application on the camera. But traditional broadcast cameras doesn't have any CPUs inside. You can't run an application in those cameras. After that, you need to transport what you captured to the cloud over the internet. And that transporting includes managing different links, it includes managing multipathing, it includes some kind of redundancy if you have some challenges on your IP links. Once you are in the cloud, you need to take the videos, typically de-encode them, and put them into raw pixel buffers again, so you can start modifying them. And then you need to be able to have the different applications in place to do that, like mixers for video, mixers for audio, graphical insertions, audio if you want to introduce files, and so on in your feed. And then you play this out. And you play it out either on traditional broadcast, on a satellite or an antenna, or you stream it, or you could, if you would like, push it back down to a traditional legacy production environment. How the system looks like this. So the cool thing now is we don't actually create only one pipeline, we create two pipelines. So we create first one pipeline that we use as a master. So that's the pipeline that everyone working with the production, they are working in this one. That's a low resolution, low latency pipeline. So that's the one where we hook up all the mixers and all the applications that are used for the production. Everything that is being done in those applications onto that production pipeline is then being fed up to a distribution pipeline that works with higher bit rates, but also slightly longer latency. This means that the ones working in production, they have a head start on what's actually going out. So they have like a couple of seconds advantage in time versus the signal that is going out. So if something happens in the picture, you can push a button and then you can switch to another camera or something, and you will actually be 2 seconds ahead or more of what is going out to the viewers. So this is an essential part of the solution, how we can kind of facilitate distributed production, because the ones working with doing the production, they're working in a low bitrate version that you can actually use on your consumer broadband service.
What we are doing right now is preparing our staff and rebuilding our galleries to be PC-based. A modern production gallery at SVT nowadays has more components from our IT department than from our the usual vendors.